here and together with my partner, and this is fluid mechanics chapter 4 relative equilibrium fluids. Problem number 1. A cylindrical tank of radius of 2 meters and height of 3 meters is partially filled with the water up to height of 2.5 meters. The tank is then rotated at its central axis at a constant angular velocity of 2 rad per second. So, determine the height of the water surface relative to the tank wall. The water in the tank is subjected to two types of forces: gravitational force and centrifugal force due to rotation. At equilibrium, the gravitational force is balanced by the centrifugal force. First, the gravitational force acting on the water is given by F, G, rho GV, where rho is the density of the water, G is acceleration to gravity, and V is the volume of the water. First, we need to get the volume of the water. V equals pi r squared times height. We all know that the radius is 2 meters and the height is of the water is 2.5 meters. So volume of the water is pi times 2 squared times the height of 2.5 meters. 25 pi cubic meter. Proceed to this formula. Gravitational force equals the density of the water, 1,000 kilogram cubic meter, times the gravitational acceleration is 9.81 meter per second squared, times the volume of the water, this one, 25 pi cubic meter, is equal to 245,250 Newton. The centrifugal force acting on the water. The centrifugal force acting on the water naman. Where centrifugal force is equal to rho angular velocity squared times 2 radius times area, where the angular velocity and the radius of rotation, and A is a cross-sectional of the water column. Need to get this area. The area equals pi r squared. So we all know that the radius is 2, so we can get the pi 2 squared is equal to 4 pi meter squared, the area. So we need to substitute this, we all know the density, the angular velocity, 2 rad per second, and the radius is 2, and we have an area. Already have an area. So FC equals to 1,000 kilogram meter cubic per cubic meter times the angular velocity is 2 rad per second times 2, the radius is 2, and the area 4 pi 4 pi meter squared is equal to 16,000 pi Newton. This is the centrifugal force. And lastly, finally, at equilibrium, gravitational force is equal to centrifugal force in equilibrium. So the equation is 2.45250 Newton is equal to this 16,000 pi Newton plus rho g area times height. So to determine the height of the water surface relative to the tank wall, we can manipulate this h, and we have the final equation of 245,250 Newton minus 16,000 pi Newton over all over rho. We all know that 1,000 kilogram per cubic meter is the density of the water, times the acceleration due to gravity is 9.81 meter per second squared, times the area. The area is 4 pi millimeter squared, 0.56 meter. Therefore, the height of the water surface relative to the tank wall of 2.5 meter, 2.5 meter minus 0.56 meter is equal to 1.94 meter. This is the height of the water surface relative to the tank wall. And that's